All right, let's take a look. Here's our basic unit circle, and we're here at 0 degrees would have what? 1, 0 would be its ordered pair. 30 degrees, you've gone over root 3 over 2, up a half. If we're here at 90 degrees, what have you done? You've gone over none and up 1, okay, and so forth. And we'll look at that all in a minute. But here's what we want to pay attention to. This first value, that is actually your cosine value. The second one is your sine value. What that means, let's take 30 degrees here. If I do the cosine of 30 degrees on my calculator, it's going to give me this value right here, root 3 over 2, which is 0.8660. If I take the sine of 30, where the sine is always your second piece, sine of 30, I guarantee it's going to give you a half, 0.5. It has to. So let's take a look here at 90. What would the cosine be? Cosine is the first value. So the cosine of 90, calculator is going to say 0. And for the sine of 90, it's going to say 1. Well, what if they said, hey, what's the sine of 270 degrees? Right here's 270. That ordered pair, you've gone over 0 and down -1. The first value is your cosine. We don't want that. We want the sine of that 270. Your answer is going to be -1. So the first value is your cosine. The second value is your sine. Now, how are we going to use that? Well, let's take our little circle. Here's 0 degrees, 90, 180, 270. Let's just concentrate on these 4 points. Well, 0 degrees is over 1, up none. 90 is over none, up 1. This is over -1, up none. And here at 270, you've gone over none and down -1. Because a unit circle, everything is unit of 1. Okay, so you've gone over from the origin, you've moved over 1 unit. Now, we said the cosine is the first value here. So let's say we're going to make a chart. Here's going to be our degrees, and here will be our cosine of theta's value. So we're going to do 0 degrees, we're going to do 90 degrees, 180, 270, and 360, which is just the same as the 0 degrees. So 0 degrees, the cosine is what? 1. At 90, the value is 0. At 180, -1. At 270, it's right there, 0. 360, you're back, and it's at 1. So let's plot this now on this little horizontal X and Y graph that we have. So here's 0 degrees. At 0 degrees, the height was 1. At 90, it was at 0. At 180, we were down here at -1. 270, it said, hey, we're at a height of 0. And 360, we're back at a height of 1. Now, if we do -90, which would be this way, you would be at 0. And if you do -180, you're going to be right here at -1. 270 is back there and there. Now, we have these dots, and it looks like it could be a straight V. If I connected them, looks like a V. Though that'd be a perfect W, wouldn't it? What's going to happen is it's going to be a wave. So what's going to happen is this thing's going to come in and do a wave like that. And that is the cosine wave there. Okay, I sort of missed my point there. But that's what it looks like. And all we're doing is plotting points. Over 0 up to a height of 1. Over 90 degrees, up none. Over 180, up or down to -1. You're just plotting points. That's all you're doing to get these graphs. And we're going to see that a lot of things work here as a cosine or sine graph. We just did the cosine graph. What about the sine graph? Well, you do the same thing. Draw a terrible circle like this. 0 degrees is over 1, up none. 90 degrees is over, over 0, up 1. Okay, over here, over -1, up 0. And here at 270, and there was 180, we've gone over none, down -1. So let's do the sine this time. So here's my degree, and here we're going to do the sine. So we're going to do 0, 90, 180, 270, 360. We're going to plot the points, and it's going to be that same wave again. 0, what is the sine? The sine is the second value, so it's 0. 90, it was a 1. 180, its value is 0, because remember, the sine is always the second value, the second of the ordered pair. 270 is -1, 360 back at 0. So if we scroll down just a touch to graph this, 0 is 0, 90 is at 1, 180, you go up to a height of 0, 270, height of -1, 360, height of 0. And if I continue, -90, remember it goes that way, would be -1. 180 would be here, here, and here. And again, it's going to go in that wave, just like our voice travels in a wave, travels in a sine wave. Okay, the internet coming to you comes through a wave, sine wave. Okay, so they travel in this way, and then we make them sort of stretch, elongated, up and down and wide. But we talk about that later. So there's the graph. All I want right now is you to be able to graph it. All I'm doing is plotting points. Makes life very easy. Right? Should be rather easy. Those are the main graphs we want to know. Sine and cosine, be able to plot them and graph them. And all we're doing is just basing it off of ordered pairs. Now, there is one trickier one that we do need to look at, the tangent. And the tangent of theta is, believe it or not, the tangent is simply the sine divided by the cosine. That's what it is, right? And I can prove it, and I proved it in class, but I know you're limited on time. You don't want to watch me forever. So let's just do the tangent, because it's a totally different looking graph and a little bit harder to follow and understand. So we have our unit circle. Again, 0 degrees, 90, 180, 270. We've gone over 1, up none. We've gone over 0, up 1. We've gone over -1, up none. And 270 over 0, down -1. Now, so if we talk our degree, we're going to do 0, we're going to do 90, we're going to do 180, we're going to do 270, and then we're going to come back to 360. Well, remember the tangent is the sine value over the cosine value, okay? So 0 degrees, we're looking right here. It is your sine value, which is 0, divided by your cosine value, which is 1. That gives me 0. Great. So I got a point right here. 90 degrees, well, 90 is right here. It's your sine, which is 1, divided by your cosine, which is 0. Wait a second, that's undefined. You can't do that. And we're going to see at 180, we're going to get 0. Here at 270, undefined again. Here at 360, 0. So we're going to get zeros here and here and here. And you would also get them here at -180, -360. But at the 90s, the 270s, you can't touch it. What it ends up being, asymptotes. Well, does our graph then just look, oops, dum-dum again. Cecil's making some mistakes today. Silly, silly, silly. I had those plotted as zeros. Maybe you picked up on that. I meant for the asymptote to be at 90 and -270. I was just being silly, checking that you were catching me messing up. So now that we have it correct, it looks like that, but wait, something's missing. Something's not right. Well, let's come in and do another degree. Well, if we came in and we did 45 degrees, remember that's √2 over 2, √2 over 2. So it'd just be √2 over 2 divided by √2 over 2, which would give you 1. So when you're here at 45 degrees, you're going to be at 1. -45, you're going to be here at -1. And as you get larger and larger, as I get closer and closer to that 90, notice you've gone over very little, and you've gone up almost the whole way, almost the whole unit. So you're going to have a large number divided by a very small number, put it in groups of smaller and smaller and smaller. That means the number gets bigger and bigger. So as we get closer to this asymptote, we're getting higher and higher and higher up. And the graph ends up looking like this. They do the same pattern all over. goes up like that, and then swings down like that, up like that, approaching the asymptote, down like that. That right there is your tangent graph. And you got to be able to think through more than just your 0, 90, 180, 270. You need to understand undefined, because you can't divide by 0. You can't put things in groups of nothing. It makes no sense. That's why it's undefined. But you're going to have to look at other little measurements of 45 and 60s and whatever. But the main thing I really want right now is be able to recognize it. There is a tangent graph. It looks completely different than Mr. Sine or cosine graph. It's the wave, right? That's what we want to be able to do. And all we're doing is we're plotting points. Make it make sense to you. Just, again, make the unit circle, plot the points, connect the little dots, knowing that you got a little wave going, and you'll have it.